Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And just a quick word, I mentioned this in a pre-calculus video yesterday, but here in the Philippines, or whatever community you're in, link up with one of the local schools and help provide books for the children at school. One of the challenges here in the Philippines is kids will take pre-calculus, calculus, whatever the class, and not have a book. I mean, there will be no books. And I can't imagine that. And so try to help, okay? Link up with at least one kid. Go give one kid a book so that they'll have something in that class, or link up with the school itself and see what the needs are there and try to help out. So why? So that together we can build a better tomorrow, and do that through math. And you may say, well, I don't like math. Okay, whatever your chosen field in life is and how you want to help children, just reach out and help. And you can make a difference and a great impact in a child's life. That's important stuff, okay? All right, tonight we're working on U-sub integration. We're just practicing, okay? I have 5 problems. Take us probably 12, 15 minutes to work through these. So, all right, let's get after it. All right, here we have, let me just get stretched out here, the integral of 6 times 1 plus 6x to the 4th dx. Okay, so let's let u equal 1 plus 6x. And the reason is, once we take that derivative, you'll see that we'll have something over 6 eventually, and that'll help us cancel that 6, which greatly reduces things here. So du is 6 dx. So the derivative of a constant is 0. Derivative of 6x is 6 dx, okay? Chain rule. All right, let's isolate the dx. So we divide both sides by 6. Du over 6 equals dx. So now I can substitute that for dx, and then u, here we go. So all right, we still have our 6, u to the 4th power. So that's 1 plus 6x raised to the 4th power. Dx is now replaced with du over 6. Voila! The 6's cancel, and we end up with the integral of u to the 4th du. It just greatly simplifies things. U-sub is awesome, okay? So now what do? We have raised that to the 5th power. 4 plus 1 is 5. We divide by 5 or multiply by 1/5. Now then, that's 1/5 u, which is 1 plus 6x raised to the 5th power plus c. Isn't that cool? I get excited, I guess, about things. I just think it's awesome. Okay, that's one down. It's my new big eraser. All right, now then, we have x. The integral of x times 5x squared plus 4, all this raised to the 3rd power. So as you can see, if I take the derivative of what's on the inside, 2 times 5 is 10, but more importantly, I end up with an x term that it's going to help me get rid of that x. Okay, so let's let u equal 5x to the 2nd power plus 4. Du equals 2 times 5 is 10, x to the 2 minus 1, so that's 10x plus the derivative of 4 is 0 times the derivative of that x. There's dx. Okay, now isolate the dx, so du divided by 10x equals dx. So now, let's go back over here. We still have our x times u to the 3rd power, and we're going to replace dx with du over 10x. Du over 10x. So the x's cancel. So what does that leave me with? I'm going to bring that 1/10 over here so I don't lose it. U cubed du. Okay, so I end up with 1/10 times u to the 3 plus 1 is 4, and divide by 4 or multiply by 1/4, u to the 4th. So that's 1 over 40, 1 times 1, 10 times 4, 5. I'm going to substitute back in for the x world here. Where was it? 5x squared plus 4. 5x squared plus 4 to the 4th power. That's not 3 plus 4 there. It's 3 plus 1 equals 4. Sorry. All right, 5x squared plus 4 raised to the 4th plus c. That would be our answer. Okay. Hopefully everybody had a wonderful day and you've been studying, working problems. All right, let's go with the integral of x squared divided by x cubed plus 3 and the square root of that, integrating with respect to x. Well, similar situation. I can see if I let u equal this, the derivative of u is going to give me a 3x squared term, and that's going to eliminate that one. So let's let u equal x cubed plus 3, du equals 3, bring the 3 down, x to the 3 minus 1, times derivative of that, which there's no derivative, or plus the derivative of that, says 0, but I still need to take dx here, chain rule. All right, so dx, I need to isolate that, du over 3x squared equals dx, so I divided both sides by 3x squared. Okay, I'm going to just go ahead and move that 1/3 to the outside. Now then, I have x squared divided by u to the 1/2. U is x cubed plus 3, and that's raised to the 1/2 power. Dx, I'm going to replace it with du over 3x squared. Well, I've already put the 3 over here, so just put x squared. But keep in mind, 1/3 is here. All right, so x squared cancel. I'm left with 1/3 the integral of u. I'm going to bring the u up to the minus 1/2 du. So now I need to, as I integrate, I still have 1/3 u to the, I need to add 2 over 2, add 1 to that. So in minus 1/2 plus 2 over 2 plus 1 gives me a positive, that's u to the positive 1/2, but I have to divide by that. Divide by 1/2 means the same as multiplying by 2 over 1. So I end up with 2 over 3 u to the 1/2. Now we're in the u world. Let's go back to the x world. So that equals 2/3 x cubed plus 3 to the 1/2 plus c. All right. U-sub is a wonderful, wonderful, wonderful tool. It just really makes it simple. I mean, like this one, here's a trig problem. Sine cubed x cosine x dx. Now sine and cosine are friends, just like secant and tangent. Okay, so if I let u equals sine x, du equals cosine x dx. So du over cosine x equals dx. Just isolated dx. Now I would highly encourage you to do this. Go ahead and say dx equals something, because then it's just a matter of subbing it in. just like we're doing with u. Now we have the integral of u cubed, and then I have cosine x dx, which dx is du over cosine x. So those cancel. So I have the integral of u cubed du. So that equals, increase that by 1. 3 plus 1 is 4. Divide by 4, which means I multiply by 1/4, same as. And that equals 1/4 u, which is sine x to the 4th power, plus c. You got to have one of those. Let's see, that's a bad eraser there. All right, we have one. Actually, I started to put a problem up here tonight where they had this tank of water that the water was exiting at a certain rate, and they wanted, and it gave you the function. I didn't put it out there because in reality, you would be the one going to the lab and saying, how do I take the water running out of the tank and make the equation? Once I get the equation, then it's easy doing what we're doing here. You know, it's not so challenging, but getting that equation is the challenge. So I'm actually trying to work on, just like that tank. What if I just gave you a list of data? What do you do with that? That's where I want to get to, because once we get the equation, we can work the math. You know, as you keep practicing, you'll be able to do that. But getting that equation becomes the challenging part, and that's what so many schools don't focus on. So I'd like to change that. Once we get more equations under our belt, you'll start seeing some more word problems, some real world, because that's what you need, okay? It may not be fun, I get it, okay? But it's what we need. We want to do a good job on the job. All right, here we have the integral of 1 to 9. Those are our limits. X times the cube root of x minus 1 dx. Well, you'll see our problem here. U equals x minus 1. Du equals dx. I'm still going to have that x. Oh, well, okay. I want to get into the u world and get rid of all the x's. What if I take this? Let's say if u equals x minus 1, if I were to add 1 to both sides, those cancel, so u plus 1 equals x. Let me just put u plus 1 in for x, and let's work through it. So u plus 1, that's x. And then I have u to the 1/3 power. That's the cube root of u, and u was x minus 1. And du is dx. Okay? Now you'll remember the rule. If you have a to the m times a to the n, it's a to the m plus n. So if I distribute that u to the 1/3 inside, this is really u to the 3/3, u to the 1. Okay, so now I have this same scenario here. So I just take u to the 3/3 plus u to the 1/3, and it gives me u to the 4/3 plus u to the 1/3 times 1 is u to the 1/3, and all of that du. Okay, now then, let's integrate that. Oops, I don't need to double integrate. All right, we're going to add 1 to this, so 4/3 plus 3/3 gives me 7/3. U to the 7/3. Now if I divide by 7/3, I'm multiplying by 3/7, plus u to the 1/3 plus 1, which is 3/3, so I have u to the 4/3. And all of that is 1 to 9. Sorry. My limits fell off. Okay, now we're in the U world though. We've got to go back to the X world. So U was X minus 1. So now I have 3 over 7 times X minus 1 to the 7/3 plus X minus 1 to the 4/3 from the limits of X equal 1 to 9. Okay, remember the big boxes that I told you to put? It becomes really important when you have something like this. At least for me. Maybe for you, you don't need. But I would encourage you to do it for a while till you get used to it. So now I have 3 over 7 plus some stuff here plus, I lost. Oh, I didn't divide by this. Oh, my bad. 4/3. This is 4/3, so I should have a 3/4 right here. Hopefully you were going, wow, he missed it. Okay. 3 over 4. Sorry about that. Okay. Minus, and I have the same thing here. Of course, there's things in the parentheses that go here. All right. I'm going to put the 9 minus 1 inside. 9 minus 1 is 8. I have 8 to the 1/3 power, and I'm going to raise that to the 7th. Recall the rule. I'm about to run out of space. A to the m raised to the n is a to the m times n. Okay? All right, so having said that, I'm going to take that 8 and raise it to the 1/3 power and raise that to the 7, which is 8 to the 7/3, which is what I have here. You know, u to the 7/3 power. Okay, that's going to be plus 9 minus 1, which is 8. So I'm going to have 8 to the 1/3 raised to the 4th power. So over here now I have x is 1. 1 minus 1 is 0. So everything here becomes 0. 1 minus 1, 0. So everything there goes to 0. Now then, the 1/3 power of 8 is 2. So 2 times 2 times 2 gives me 8. 8 to the 7th power times 3 gives me, and I've written that down over there for the sake of time, 384 over 7. Plus 8 to the 1/3 is 2. 2 raised to the 4 is 16. 16 times 3 is 48. 48 over 4. Okay, let me make certain that's all right. We're good. Now, let's change all of that to least common multiple of 28. So I would be multiplying this by 4 over 4. This one by 7 over 7. Okay, so if I do that, I end up with 28 in the denominator on both sides. If you add those up, you get 1872. 4 will go into both of those. Of course, you know the last two digits, I can put 4 into that. So that means 4 will go in. I know 4 will go into that one. So I end up with 468 over 7. And that would be the results of that definite integral. Well, you can see the value, though, to being able to say, here's u, but then I still had the other x term, but since I've defined what u is, I could solve for that in terms of x. So that worked out well to eliminate that x. Okay, that's enough for now, I guess. Remember what I said earlier about link up with a school, try to give a kid a book to be able to study with in school, help them out so that together we can build a better tomorrow. It's not just about just working some math problems. It's about moving the needle in the world to help things be better. Okay, that's what we're all about. I can't work, I have spinal stenosis, but I'm doing all of this just to try to give back something So let's help these kids out and make a difference in the world, okay? All right, that's enough for now, and we'll talk to you next time. Thanks.